what's up, guys? Hopefully, everyone's doing great. I'm Fatalam. Today, I'm gonna do some Labtainer lab work. My today's lab is intrusion prevention and the detection. For the prevention, how do we prevent any kind of intrusion? If you plug in the firewall in between our server and the client. So if you see in the graph, if you put a firewall and make some traffic changes, like you can see, we can fix that. We can fix some unexpected attack or something. The Snort is Snort is also an open source application that is used for the detection. So if anyone try to attack in our system, we can get some alert like, hey, there's a problem is going on. So for this lab, we actually use two lab. One is the IP tables and one is for Snort lab. To start the IP tables, so we're gonna open in the terminal. We have to type labtainer IP tables 2. So it will be labtainer IP tables 2. As it's working, we can discuss something in here. Okay, so the labtainer is very important. Like the IP tables, we have to fix something in the tags. We have to do Wireshark and stuff. Okay, so in here it just asks for my email address. I don't want to use my email address, so I'm gonna use my name over the stuff. So it will be like for the long, right? So okay, as it should work. So first we have to do in the first task we have to open the Wireshark in the firewall terminals to see ongoing traffic. Then we're gonna use something in here. That's good. Then blah blah blah. Okay, that's good. Got it. Let's start like okay. So starting sometimes takes time, but yeah, these videos behave long because um, this takes a little bit time. Yep. Okay. So now we start. Perfect. Great. So okay. So after you start, we see there's a two terminals this pop up. One is a firewall and one is from the client. What's the difference between the firewall and client? Like firewall, we just use our configuration and stuff, and inside the app firewall and the client, there's a what is called like sorry, inside the client and the firewall, there we have to figure something out, right? So first one we have to do nmap server. No, not the firewall. Find the Wireshark. We have to open the Wireshark first in the firewall terminal. So if you do Wireshark ampersand. Normally, we don't need ampersand. It's only for the Labtainer use ampersand sign. So let's see. Perfect. Opening the Labtainer in here, they ask for select the Ethernet 0 cables, the where we can find the ongoing traffic in here. So after we open one in here, perfect. Then we're gonna send some traffic. First, we're gonna send nmap server to see what's going on in here. So nmap. Oh, by the way, let's see what is inside of here, right? It has whizbang. Okay, that is a mistake. And the Wireshark, it has example script file. So in the Ubuntu, if we do nmap map server, server is the firewall. So okay, this is the firewall. So if we do the server nmap server, let's see what do it looks showing something in here. Or is here map? Yep, you're correct. Let's see. So it's supposed to see something in here, but also you get some traffic. We should get some traffic too. Let's see what's going on in here. The network is working, I guess. Yep. What's wrong? Okay. After you click again, it's going to show somewhere. Perfect. Okay, so we found something in here, which is nmap has a 3 port is open. One is 22 port for the SSH, 23 for telnet, and 80 port is HTTP, right? So the 3 ports are opening. 3 ports are open, so we can use any kind of like those 3 ports should open, right? Okay, that's good. Now, if you do the wget server, And by the way, when you do the nmap, we see there's a lot of traffic is dropping, right? It doesn't go through over there. So if we clear this up again, uh, and do something like clear, then wget server, right? Wget server ampersand wget server. Let's see. Okay, we found some traffic, which is if you go in here, it says use the wget server client terminal to confirm that the server responds to the HTTP traffic, right? We see our server is respond the wget server. It's not dropping in or anything, right? So this works perfectly fine. Then if you stop this one and clear it up, and also clear from the Usher 2. Now the second command we should use, it says confirm an SSH server is offered. You need to log in, or you don't need to log in, just come to see. So we just want to make sure that the SSH is working or not, right? So if you do SSH, not in here, this is not in here. Okay, so it will be SSH server. If you plug in here, you don't have to do this one. You just type like yes, you want to go. Okay, but you don't have to log in and stuff. You see, this SSH server is still working. The port they're using port 22, and it's totally perfect. So they can contact like clients hello and hello, right? We can find this one, right? So that means the SSH works very good, like it's perfect. Then we're gonna finally use the telnet server, same thing. So we don't need to log in here. So from here, if you cancel it and clear it up and do telnet server, we probably see some traffic in here. Here we see, you see the telnet traffic is here. So there's a lot of telnet traffic because they're trying to communicate. It's not dropping, it's really perfect and fine, right? So okay, we can clear the Wireshark and the client server. What is this? The second step we have to do, observe the traffic in the Wireshark, making the node an IP address and destination port using the client. Observe that traffic in the Wireshark, making nodes on the source ID, IP address. We already did destination port. Okay, we already did, and use the client. You use the server. Okay, perfect. Now use the IP tables to limit traffic. So I know the IP tables utility installed in the Wireshark component is already in there, used to prevent the firewall from forwarding any traffic to the server other than SSH and the HTTP. So if you use any kind of other than HTTP or SSH, you should see like the traffic is dropping. So what should you do? You may refer the IP tables new traffic server other than HTTP. Okay, so as they're saying this one, so how about we can look at here the firewall. So example, how about we can read first, right? Sudo nano, you can use the VM too. The both are good, right? So in here it shows like IP tables, okay, allow the SSH traffic to port 22, but it doesn't allow SSH, right? So we have to configure SSH first, then maybe you can solve it, right? So how about we can go here. Oh, sorry. So if we do, just make a small comment, allow HTTP traffic on port 80, right? HTTP use the 80 port. So you're gonna use the same things on the top, IP tables, then for a forward capital letter, then port is TCP, then dport 80, right? We're gonna use 80, then accept. Everything looks good, right? Okay. One more thing's in here. Okay. So one the small note in here, the note that last line of the example is to detect the IP tables to log dropping packet. So it just detect the IP tables to log dropping packet. You can view this on the different way, but you can see the nano is working too. So there's the same things. But then we have to save it, Control X, then Y, then enter. Perfect. Now, if you run the code, how do you make sure this is working? Like, if it's it's not working. How do you already, you already see. This is what we wrote, right? Now we have to run this code. How do you run this code? You have to put the sudo dot slash example is perfect. If you don't see any kind of error in here, that means our code is perfect and good. Like we can run this, we can run successfully. Then one more things about that I told you before, like you can see the last line of the code, like last line of the example that there's a different way you can see, which is tail slash f var log iptables log. Let's see, we can do this one tail, then dot f, not in here, I'm sorry, in the firewall. So it will be like tail dot f slash var dot, it was log, I guess. No, log, yep, then iptables log. Log, then iptables dot log. Here, if you don't make any mistake, var. Okay, yeah, I know this takes a little bit time, but hopefully you can see something in here. Then after modifying the IP tables configuration, we already modified, we add port 80, we open the port 80 and the 22. Everything else it should be dropped. Use the application on the client to demonstrate that the firewall only will allow the desired traffic. Was the IP traffic in the Wireshark to see that the TCP handshake failed when attempting to connect to the filtered port. Okay, I don't know how long it's gonna take, so you can stop it, but normally it takes the same things, like you show the same extra line right now. But yeah, but we can try again, I guess. We have time. There's tail f, okay, slash var, okay, slash log, slash IP tables s, then log. Yeah, it should work. I don't know why. Maybe my PC is super slow, that's why. Okay, so now if you go to the nmap and see what's going on in there right now. So first one, we have to stop this. Then do nmap we did before. Nmap server. Let's see what's going on. Yeah, I told you like it takes us okay forever. Okay, so now we see the two. You see the difference. Before is the two port is open. Now there's only three ports open. Telnet was open too, right? But now there's a two only, which is SSH and the HTTP port is open. So now we successfully do this stuff, right? So let's see. I can do any other things in here. We have a different things, but we want to make sure like everything is working or not, right? How do we make sure? Like if I just filter it out, like I cancel, make sure everything's all right. Um, in here maybe we can do telnet server. So as I told you before, the telnet is not supposed to get the traffic, like it should drop in this trying. You see this is trying, that trying, okay, perfect. And in here you see that this is dropping sign, that means it's good. Perfect. How about if you don't use the telnet, use the HTTP? So you remember HTTP use a wget, right? So wget wget server, boom. So we found something. This is HTTP is working totally perfect and fine. So we are good. Like we are really good job, right? So you can stop in here. How do you stop? Okay, stop. Cancel everything. We can clear this up. Then we can clear our firewall too. Select for the next things to do. The next thing, the open new server port. Like the client computer include a whizbang program that must not allow to send traffic to the server. Okay, so in the client server, they have some specific program that can go through the firewall. So use the Wireshark so we can run the programs, the client terminal window, and observe which port is using. To run the program, we use the whizbang server, okay? The out of the servers and the nmap server and blah blah blah. Okay. Okay. So in here maybe we have a whizbang server. How do you maybe before we write it down, we can see what is inside of the whizbang, right? You can see sudo nano whizbang. This is good. This is a Python using bin script file. Okay. The input socket and stuff. Okay, that's good. Okay, there's a good things to know. Like They're using a port uses 10090. That is their port they're using. The server host 100.3. By the way, what's my firewall host? Like, let me config, ifconfig. Let's configure the Mac, Windows and Mac. So this is 1.24.3. That means maybe this is shows by the what is my IP address, right? What is the config? Client IP address is 0.3. Okay, 172.24.0.3. So if you do whizbang nano, that means their server 0.3. Yeah, that's been there. This is their IP address. Okay, perfect. And they try to communicate with the port 1090. Okay, let's try and run. Let's see. Right? So if we clear this up in here and in here too, the washer, maybe it's perfect. In the washer, maybe you can type / whizbang, then server. We're gonna try to communicate with the server. Um, they're trying to connect, but if you go whizbang server, yeah, perfect. Then okay, perfect. So you see, they're trying to communicate with the handshake protocol, but it's dropping because they don't get the response from it's dropping in the firewall. So that's why the red flag shows in here. You see, maybe you can find details in here. There's a flag, not reserved, and Windows try to communicate, and it's not anything. It cannot connect establishment. Okay, so this is the port number they're using, right? So if you go to the STP, you see the port number, destination port 1090. Nah, it's not working at all, right? So how about the top? The destination port, this one, the same things. Yeah, the port is dropping. Okay, so how can we fix this port? We cannot fix in here. There's nothing to do. In the firewall, maybe we can fix it, right? How do you fix it? You did it before. The fix it, we know we can do the same things in here. Sudo nano example, because there is some command in here. Before we use the HTTP protocol, right? Now we can use one more command in here, or we can say allow. Maybe this is whizbang traffic on port. I mean, it's good to write a note. Otherwise, you cannot remember what's doing in here, right? So whizbang basically traffic to port 1009. So we do the same things in here. $sign iptables dash a forward. This is my new keyboard, so I'm not comfortable with that. TCP D port 10090. Then we're gonna accept. That means our IP tables, we're gonna forward the IP tables, and this is TCP protocol. How do you know this is TCP protocol? If you do to run the same things, sudo nano, you'll see something in here. Is it here? I don't think so. No, it's not in there. But I can find in maybe in the Wireshark. Yeah, they're the TCP protocol, right? This is the TCP protocol. That's why we use the TCP protocol, port number 10090, and we're gonna accept this one, right? Then Control X to save, Y, enter. Okay, then after you write it down, it's not finished yet, right? So you have to run the script file. How do you run it? Same we did before. Sudo dot slash example, if w is an example. There's no error shows, that means we're good. Now, if we go to the Wireshark and clear it up everything and make sure everything is fresh and new. So we do the same command sudo whizbang server right now. Now, before it cannot go through this one. Now it's supposed to go. Let's try. Enter. We see this is working perfectly, sending instruction server. This is bye bye. then the port is 10099 is totally perfectly going on the server, right? That means we totally perfectly do this one. Uh, yeah, so that's the for the IP tables, right? So we can stop this lab for only for the IP tables distribution system. Stop lab, right? So it should take a little bit time. So our lab part one is finished. It's now is going for the lab two. Now we have to go for the lab two. Make sure this is stopped. I don't know why it takes so long, but let's go. Yeah, it's working. Perfect. Now, if you go to the lab two, it says this exercise introduces the use of the Snort system that provide intrusion detection within the Linux environment. Student will configure simple Snort rules and experiment with the network free detection system IDS. Okay, short video, blackboard. Okay, I don't need that. So here's the things. This is your server, and this is the gateway. So Snort is installed 3.1 in here, then 192.168.2.1 in this IP address, this workstation. It's an internal traffic. This is my web server. Everything goes in that gateway. They follow the gateway and goes to the cloud. Then the remote server, there's a remote gateway over there, but remote server is 172.16.1. Okay. The gateway source traffic from the IP address, blah blah blah. Okay, we're gonna learn this one by doing this. So we can do Labtainer. What was that? Snort, right? It was not. How do you start? Yeah, Labtainer Snort. Enter. So it takes a little bit time. As it takes a little bit time, what should we do? We can research on something else. So this graph is very important. Like we have to follow this graph. Who has what? This is gonna show you. So let's see if the internal traffic. There's two peoples. Their IP address is three. One is 3.1. One is 2.1. They goes to the gateway in the cloud, remote, and the gateway. Okay, perfect. It asks my name. Just press whatever you want. It takes time, right? Yeah, I know. Then the gateway is also configured to mirror traffic into the gateway via 13.10. 13.10 here. Mhm. So the web server runs Apache and it configured to support SSL. SSL is the secure socket layer. Now for web pages in the www.example.com domain. So the domain is www.example.com. Perfect. Then the remote workstation component, WS means workstation. The firewall, the host map. Okay, start the Snort. Okay, it's already ready. Snort is ready. So okay, we see the three different terminals open. One is for Mary, Tom, and this one's the Hank, which is remote server. Make sure everything is correct. So there's a for workstation W workstation 2. This is the if you do ls, see there's nothing there happening here. So you see the Snort is in the Tom directory. The Snort is Tom directory. So his IP address supposed to be ipconfig 192.6.3.1. Is it 3.1? Yep, 3.1. That's mean this is my directory. This is my Tom's directory. This is Mary's directory. Then we have admin, the web server. This is the gateway we're gonna use. This is the gateway we're gonna use. Then this is the remote server for the Hank. Hank IP address config 0.1. So 0.1, this one, right? This is the Hank's directory. So okay. First things we're gonna do, start the Snort and go to the network topology, network out the gateway. This can be seen the following etc rules. Okay, the IP tables getting in particular consider the IP tables on the gateway, IP table settings on the gateway. Okay, that means in here. and there, gateway, right? Can seen by viewing by the command etc rc.local. Okay, we can do cat command etc.rc.local. Is that? Yep, yep. That means in here, if you see the pre-routing LAN port 433, port 82, and port 444. Okay, we can find the good things in here for stuff. We can clear this up. Then we're gonna do this one in here. Um, Pre-configure the snort rules. Okay, pre-configure. Why? Because you're gonna know suspicious traffic activity. The confirm the snort largely and exist in the initial traffic. Snort example of the snort pre-configure rules. Perform the scan and map scan for the remote workstation. So from the remote workstation, we're gonna send some traffic like example.com. And by the way, these are example.coms. This is inside our server. Like this is inside our office and stuff, right? The workstation. So if anyone from the outside traffic can, like if I start the snort, how do we start the snort? Start, then start snort. The start snort is already inside of here, right? Before I start, I can. It's better to look at here, right? So why we don't clear first, then nano, or you can do cat, right? It's much better to use the cat. So there is nothing in there. It's totally blank. There is nothing. So we're not supposed to see um, any kind of detection here. So let's try. From here for the hang directory, if you clear this up and type www.example.com, is it example.com? No, it was sudo nmap. Okay, sudo nmap www.example.com. If you press enter, you see some open ports 443, 8053 for domain and 22. Domain supposed to go work, right? And it shows the ICMP ping, someone's ping us. That's the things we're gonna see, but it doesn't shows anything like a detection or something, right? How do you fix that? How do you fix those stuff? So in the Tom's directory, if you cancel this up and clear, and in the start snort directory, if you write some code in the script file in the Tom directory, we're supposed to see something in here, right? How do you see this one? If you do like a sudo nano then rc slash snort slash rules rules rules. If you press enter, um no, it's not in here. If it's not sudo, it's supposed to be ls. If you put ls, yeah, those are the rules we can find in here. That's what it is saying. Like if you do the now with the alert display the snort console, the rules of generate this alert can be seen along with the all other rules. So every rules is in there. So any kind of rules is you are looking for is everything is there. But we're gonna see some specific rule. We're gonna how do we fix it, right? So snort rules, local rules. So maybe we're gonna fix these rules, the local rules. How do you do this one? Clear. Then if you type sudo nano then slash etc slash why this is local rule, by the way, because um, right, so after you do the sudo nmap www.example.com, we see some the spin command, they don't do anything, right? So that's why we're gonna write a simple bad rules, simple bad rules, like with just any kind of traffic is coming through this one is gonna pass through and give us a detection, like anyone. So it doesn't matter like is it internal traffic or the outside external traffic. So how do you fix this one? All the rules I told you before this is in the etc snort rules dot locals root directory. So if you go there now, it is empty, right? So how do you fix that one? So you can go to the etc rules, sorry, it is snort, snort slash rules slash local rows, right? If you enter, you see this is nothing in there. Everything is empty, totally empty. So for empty in here, as is empty, we have to write something in here. What should we write? We should write alert TCP. So it's gonna alert us something. TCP port, any kind of TCP protocol, any kind of destination IP address and source IP address, source, whatever is there, we're gonna show some traffic alert, right? So how do you write it down in here? So you say alert TCP, sorry, it should be alert TCP, then any, then any, then the message MSG message is it can be anything. So you can say this is TCP detection, right? TCP detected, then close this quote mark, then ID, so ID is 0000004, and then close, right? Make sure this is correct. TCP, TCP detected, code TCP detected, TCP IP, perfect, we got done, right? So we can control X, then Y, and enter. So save it, right? After we save it, it should work, I guess, right? It should work. So anyone from the outside the traffic, and give the rules identifier 000002, right? 0002. Then restart the snort. Then test the rules by starting Firefox on the remote workstation. Now, if anyone from the outside our traffic try to see what's going on in the website, and we're supposed to get some traffic in here. How? But before we start that, we have to open the snort in here. So for opening snort, we can do clear. Oh, no, we can do this one first. Start snort, right? So now in the Tom's directory, which is outside of traffic, they're gonna use firewall. Sure, firewall. Sorry, Firefox. Firefox www.example.com, right? Let's see if. And by the way, this is not the regular firewall. They're gonna they make a new firewall. My computer likes to time. Yeah, so this is my the basic command traffic, and you see whatever you see, we see the TCP detected. That means our detection, any kind of traffic from outside, it should work like, hey, somebody's trying to get a TCP, right? TCP communication. Now, if we go the second one, custom rules for confidential traffic. The confidential traffic at the Firefox browser, which should be displayed at the web page, example, will be displayed unpublished web pages that will know the exist of the website. Okay, there's an unpublished website which is we found after the example.com. It should be, I don't know why it's not working. Is it that here? I don't know. Okay, so in here there's some slash. If you do slash plain.html, that's a different things, right? We're gonna see some traffic. We're not gonna enter yet, but then it says plain.html. Look at the look page now. The rules of the local rules file the snort that will generate alert whenever the text confidential sender to a traffic. That means anyone try to use our confidential information outside the traffic is not published in the website, the plain.html. So if anyone try to see our traffic from the outside, we're gonna get some detection detected, right? So, but how about we can see first? We can cancel this out. First, we don't need that anymore. How about we can do Firefox slash plain dot html, plain.html, right? It's supposed to be plain.html, and here we can cancel this up and start the snort again. But let's see if it shows anything in here. It just says TCP detected, same as the before. It doesn't show us like this is a confidential stuff, right? So that we have to make something the different, like and anyone can show can go our confidential information. we should get some detection alert, right? How do I get the alert? You can stop the snort in here, right? Cancel in here too. Then if you clear this up and go to sudo etc roles, if we go there, instead of the any alert TCP any, then it should be content semicolon quote mark confidential, then close this quote semicolon, the message TCP detected, that we don't need that TCP detector, it should be confidential stuff, confidential detected. So the message will be confidential detected, closing code, then semicolon, then SID will be 0002. Everything should works perfectly. Let's before go jump in there. Let's see. So it will be confidential. Send it out to the network. So the confidential for the alert TCP, we never change this one. For the content, we just add this is a confidential content. The message will be confidential detected, and the SID will be 002. Okay, perfect. Now we have to save this one before I make sure you can. Okay, so Y enter. So now we just fix something in here. How about if you run the command again? No, it's not smart. Oh, okay. So you see there's a little bit spelling mistake in here for my. It will be MSG. MSG. Now save it. When you save it and start the snort, it will give you some alert. So now it's as it not showing anything here. That means our alert we can perfectly implement, right? So let's try from the DOMS directory again. Firefox plain.html. Can you see some traffic? Any kind of configuration lives in here. We're supposed to see. It is confidential, but the problem was every time it goes in here, you have to clear some advanced basic stuff. If you don't do that, sometimes it gives you like error and stuff. Okay, but cookies. Okay. Okay, so again, we can run the command again. Let's see. Mhm. We found the conflict detected, right? And that's the make sure one more thing is also it's already in the measuring here. Sometimes you cannot find the stuff, so you have to clear your history. Like when the browser add the rules, register the workstation, clear the history, menu preference, privacy, the refresh the HTML because sometimes it's good. They still keep the cookies and stuff. So yeah, so we get that detected, right? The second things they're telling us effect on encryption. That means the socket layer function, is it working? Do you see any snort alert? Why? Blah blah. As this is still opening, let's try in here. This is HTTP, right? This is HTTP protocol. If you do HTTPS instead of HTTP, because in here it says change the URL HTTPS. Do you see any snort alert? Why you don't see any snort alert? Uh, it should be on the website or no? Back to the button, alter the URL to make uh, now alter the URL to make use the web server SSL function. Okay, so in the URL, right? If you do in here, press enter. It's not working, but same things in here. We don't get any kind of detect. This is okay. So we don't see any kind of detection in here, any kind of alert in our snort because the if when you do the encryption stuff like SSH or the HTTPS, it doesn't show you in here. When you do the change the encryption, it doesn't show us. So one solution for the problem is to resolve proxy in front of the web server. So we have to use the proxy. The reserve proxy would not be in the traffic and the SSL connection, so we'll not going to pursue in this situation slab. So you can just say this is not going to work. I mean, as the question asks, do you see any snort alert? No, we don't see any snort alert because this is the encrypted that does get encrypted and it goes to like it's just manipulating the stuff. This is not a HTTP protocol. That's why. So how we so far we've done the external traffic. How about the internal traffic? If somebody inside our network um, try to use the website, are you able to I mean, are we able to see any kind of alert in here? For this one, you can cancel the website. Cancel this up. Okay. So in the manage directory, if we send a traffic, which is nmap sudo nmap www.example.com. I'm not enter yet. I'm just before I entering this one, I have to fix something in here. Like we have to open the snort. So if anybody is trying inside our traffic, is it we get any alert in here? Let's try. If you press enter, it's starting the nmap, same things, but we get something. That's good. But what I did, we did nmap, but we get ICMP echo reply, and the reply just reply back. It doesn't show us an alert and stuff. That means there's a problem in here too. Like we cannot see any kind of nmap. They're doing try to do nmap from our local server. How do you fix this one? From this one, you see that we both are connected, like the snort and the tom, and this is the tom and this is the Mary. They both are connected to the gateway, right? So in the gateway, you're gonna fix this. In the gateway, they're gonna make a mirror. So whatever they're trying to do, it goes to the snort. So if you go to the gateway, which is here, Ubuntu gateway, there's nothing in there, but you have to go to the sudo nmap /etc /rc dot local rc.local, right? Sudo nmap rc.local. Sudo nmap. No, it's not sudo nmap. Sorry, so it's not sudo nmap. It's supposed to be. Okay, we have to clear this up first. Clear. Then it will be sudo, not the nmap. It should be nano. Nano. If you do the nano, let's see what is there. There's a lot of traffic going on here. So the mirroring the traffic in the LAN W and the Wi-Fi LAN 1, if anybody goes from outside the traffic 3.1, so from in the snort, it should go to the snort. But we are using LAN 2. So that's why you're gonna add one more things in here, because as Mary and us, we're gonna using the LAN 2. How do you know? Is it there? Yep, it's LAN 2. Everything will be remain the same. So if you go add one more things in here, IP tables, D mangle a pre-routing high $sign LAN 2 z tw dot dash dash gateway 192 168.3.1. So make sure this is correct. LAN 2T gateway 193.1. Everything should correct. So now we're gonna save it. Control X. What? Yes. Is it saved? I don't know. Oh no, it doesn't save. Okay, why is it not saving? I don't know. It's done. T mangle a pre-routing $sign 1 2 D gateway 192.168.1. Control X Y enter. Yeah, now it's working perfect. So why it's not working, right? So by the way, this is the local rule. We have to run this rule before we implement, right? Because this is inside. So we do the same things. Instead of the nano, we can remove the nano. If you put just sudo etc slash rc local, if you don't see any error, it's supposed to say okay, and the DNS MX services, no such process. So that means our the script file runs perfectly. So now if you go to the nmap, do the same things. We don't need that anymore. So stop the snort again and start in the manage directory. If we clear this up and do the same thing, sudo not the nmap, yes, sudo nmap www.example.com, and if you open the snort again in here you're gonna open this node again, right? So if you do sudo nmap example.com, we are supposed to see some traffic, which is set. Now we see the ping nmap command, right? Before it was very different. It's just like a ICMP, just times and request and fall. Now you see we're gonna find some ICMP ping command, which is great. This is what we were looking for. That means inside the traffic, if anybody in the local host they're trying to nmap, we're gonna get something in here. How about if somebody inside of a traffic Mm, distinguishing traffic by the address. By the way, this is how you run the traffic. Sudo etc local, right? So now register the song again, we get the nmap, right? Distinguishing traffic by addresses. Now, if the employee in our like local system, they try to use our plain.html, what does it show? It does give us any kind of things. Let's see. Start the snort. If we go the firewall from here, sorry, not firewall, Firefox, www.example.com/plain.html. Let's see. Is it, we cannot, okay, we don't need that, but we need this one. ICMP direction unreachable port. Who's doing us? 203 0.113. Is it shows the same IP address? I don't think so. The mesh IP address is different, right? 192. That means it doesn't give me the accurate alert, and this is the problem in here. How do we fix that one? So if anybody employee in our stuff, if they're trying to do confidential, they are supposed to see the confidential stuff, but it should be accurate, like somebody who's really the IP address. So I'm gonna stop this one, Control C, and clear this up. And if you fix that in the snort directory again, how? If you go to the sudo nano etc snort rules local dot rules, right? If you go over there, now we're gonna fix in here some little bit stuff in here. How do you fix it? Okay. Alert, the protocol you're gonna use, like which is TCP, then source address, this port will be any kind of port is fine. So our source IP address will be, this is the Merrick's workstation 2.1, right? Sorry, 1.2. 1.2. This is my source IP address. This is the website. They're gonna respond something to me, right? So this is my source IP address 1.2, and it should goes to destination address and destination port. My destination address will be here, the gateway. From website to the destination, if anything goes from the website to the gateway, we should get some alert. If anybody is inside our, anybody goes like inside a local system, they should goes through the gateway. Gateway is the center point. So if a web server sends some traffic to the the gateway in the local peoples, we're gonna get some traffic. We're gonna see some alert, right? in here, by the way, one more thing's in here, we're going to use 24 bits, the IP address. So sometimes 0 to 24, anyone, the maximum we use the 24 bits. How do you fix them then? Our in the Tom directory, the Snort directory, instead of the any, we're gonna put number 192.168.68.1.2. This is our web server IP address. From the port the port value, we're gonna leave it like that. Any port, but we have to use from 1.2 to 24. Maybe 20. Then it will be 23. 23 people can access the server, and we can get some alert in here. Then from our destination port is the gateway, which is 192.168.1.10 from 10 to 24. The gateway has different people, so different IP address, right? So everything will be same. Confidential detected, message confidential detected. Save command. Okay, I'm gonna save it. Control X, Y to save it. Then press enter. Perfect. Great. We're doing great job today. So now if you run the nmap command again from the, now we're gonna run the snort again. And before we do this one, we have to cancel this stuff. Okay. And go to the manage directory and do the same things before we did. Let's see plain text. How would it clear first? Right? It's more clean, right? Firefox plain.html. Are we getting any traffic? Wow, right. So now everything looks good. Now every traffic that goes over there, it shows it. Um, we just fix that. Yep. Then the snort rules of the IP address are used to denote that the rules of the net, all traffic of the web's destination external address will be destination address to the gateway. While web traffic designed for the internal user will have destination address that match the internal user. Okay, for this step, you must set your snort rules and traffic mirroring such that internal access to the business plan generator and alert. We did it. External access. So external address means the Tom directory. So if you go to the Tom directory and do the same things, maybe you can see some traffic in here. You can clear this up. Then start the snort and Tom directory from the hang. Sorry, not the Tom hang directory. And if you do Firefox sudo nmap, you can do sudo nmap. Sudo nmap example.com/plain plan.html. Let's see what we have to say. So we see nmap. If you do the nmap example, ICMP detection. Which one? Sudo and example. Oh, we don't fix for the confidential stuff, but we fix for the example, right? That's the way. Now we're gonna see something. ICMP ping command, right? That's the thing for the external traffic, for the only for the external traffic. And if you do the internal traffic, we can stop this one first and clear this up. And if we do the internal, from the internal, cancel this stuff. Same things for the internal, we do the sudo and map example. We are supposed to see. Oh no, we don't start that yet. Sorry, my fault. Start the snort, then we're gonna do the same things again. Sudo and map. You see, we see the same ping command. That means internal and external, whoever trying to reach our server is gonna show some alert. That's the things for the lab, I guess. There's nothing we can do. Then you can finish the part. I know this is more confusing in the bottom in here, but I guess yeah, that's the things we have to do. If you fix the snort rules, then try with the traffic by address. Then observe the snort console. They will not do. Oh, this is not do anything, right? Because the stream might of the thread up due to their configuration business without address error fine, but they don't want to monitor internal computer for suspicious traffic for NMF scan. So NMF scan is really suspicious, but if when they're doing the internal traffic, maybe they're trying to see something in here. So it's not really suspicious internal traffic, but outside the traffic, this is very suspicious. That's why they use like any kind of alert in here. But for this one, the Snort doesn't add anything alert. So you see the same values as before, I guess. Yeah. For this one, whatever we found in here, it's still the same values in here. Yep. For by doing this one, this is we done the lab. We can stop the lab in here. Stop lab and press enter. This should stop now. I know it takes a little time, right? Yeah. This is okay. Perfect. Stop now. Citizen. There's by the way one more thing. So if you go to the Labtainer, this is my professor name, I guess. The Snort. You see some lot left file. This is kind of like a zip file stuff. Yeah, by doing this we are finished the lab. Hopefully everyone's understand a little bit. If you don't, you can comment in the chat, I guess. Yeah, I try to fix me if I can. Yeah. Okay, so that's for now today. Thank you. Have a good one. Bye bye.